Okay, let's go back and let's visit these valence electrons that I told you about. Okay, now 8 is the magic number in order to form a compound. So all of the elements in group 18 cannot form compounds. They're called noble gases. You will never ever see one of the noble gases found in any compound anywhere on Earth or in outer space. And so what I've done now is I have written little positive and negative numbers out here, which simply means if an element in group 1 gives away its one valence electron, it becomes a positive 1 ion because it gave away one electron, which means it now has one less electron and it has more protons than electrons. So its overall charge, electrical charge, is now positive 1. Group 2 can give away 2. Group 3 can give away 3. Group 4 can either give or take up to 4. Group 15 can take 3, because when it takes 3 electrons that have a negative charge, it now has more electrons than protons, so it's a negative ion. Group 16 can take 2 electrons, and group 17 can take 1 electron. So when I'm trying to create new compounds, if I want to try to create a compound using magnesium, okay, magnesium on my periodic table is in group 2. So since magnesium is in group 2, it is a plus 2 ion. And if magnesium wants to form a compound with, say, iodine, okay, iodine is in group 17 on the periodic table. So iodine is a negative 1 ion. And what this means is that magnesium, in magnesium's outer shell, let's pretend my symbols represent my nucleus. In its outer shell, it has 2 electrons that it wants to give away. Okay? These are called dot diagrams. I don't know if you'll ever have to make these or not. Iodine is in group 17. So iodine has 7 valence electrons. And we use these dots to represent the outer layer, the outer ring. Well, magnesium can give away this 1 electron, but it has an extra 1. Now, iodine was one of our special elements that was diatomic, meaning that it always came in pairs. Okay? So in actuality, I'm always going to have 2 iodine. So I have another iodine right here that also has 7 valence electrons. So that this other electron over here with magnesium can come right here. Okay? Now, when you have a compound like this now, you always write the metal first and you write the non-metal second. The metal is the first name, like Lindsay. The non-metal is the last name, like Stevenson. Okay? So when I'm trying to name this, I call this magnesium, but I don't call it iodine. Okay? Now these 2 elements are married, and so iodine's last name is going to change, but it's not going to change that much. Instead of it being called iodine, I call it iodide. Okay? The IDE is what you change the non-metal's last name to. Okay? So let's say we're looking at salt, which is Na and Cl, sodium and chlorine. Sodium is found in group 1, so it has 1 valence electron it can give away. Chlorine is found in group 17, so it has 7 valence electrons. It needs 1 more. So sodium is going to come over here, and now they're attached with 8 valence electrons, and they're very, very happy. So to name this, it's called sodium, and instead of chlorine, I'm now chloride. Okay, because now we're married. It's like going from Miss Chlorine to Mrs. Chloride. Okay? If I was to look at, now, if you'll notice, this is a metal. This is a metal on the periodic table. So when you have a metal and a non-metal getting married, okay, then you take the regular name of the metal and you take the non-metal, you drop the ending, and you add IDE. Okay? So, if I wanted to make a compound out of calcium and carbon. Okay, calcium is Ca. It's in group 2, so it has 2 valence electrons that are available to carbon. Carbon is in group 14, so it has 4 valence electrons. Uh-oh, that's not enough, is it? Because 1, 2, 3, 4, 5, 6. So, before this can happen, I have to have another calcium hanging out. Okay? This is the law of conservation of mass, and this is also one way that you can balance equations. Now, here is my compound that I've made. How many calcium do I have? I have 2 calcium, and I have 1 carbon. Okay? But that little 2 is going to come over here. I'm sorry. That's my fault. So now, I don't worry. I don't care that I have 2 calcium. When I name it, it's calcium. And my carbon is a nonmetal, so I'm going to call that carbide. See, there's my IDE again. Okay? Now, if we're looking at 2 nonmetals, like water, okay, let's start with our valence electrons. Now, remember, in order to do anything with 2 nonmetals, I first have to look to see if they're diatomic. And these guys are. Okay? So I have 2 H's and I have 2 O's. So when I draw them with their valence electrons, here's what I have. Oxygen is in group 16, so it has 6 valence electrons. And remember, I have 2 of them. Okay, so these 2 hydrogen are going to come over here. And I need another set. So that they can take up the spaces in the other oxygen. Okay? So now I have 2 H2O's. Oops. And this is called, now we don't count the big numbers when we're making our names. Okay? We just look at the elements that are in it. Because these are 2 nonmetals, for some reason they think we have to count this little 2. So when you have 2 of something, you call it a di. Okay, di means 2. It's dihydrogen. And I only have 1 oxygen, so that is Mon for 1, ox-eyed. The naming compounds is really hard, and personally I think it's silly. But I'll help you with any ones that you need, and all you have to do is email me the examples. Okay?